All right, today we're pulling back the curtain on something huge, a concept that pretty much runs our modern digital world. It's called event-driven architecture, or EDA for short. And it's the secret sauce behind everything, from those instant notifications on your phone to the massive data processing that keeps the global economy humming. Now, this isn't just some techie jargon for engineers, it's a really fundamental shift in how our digital world actually works. So let's dive in. So, have you ever wondered how your bank does that? You make a purchase and instantly you get a notification, maybe even a fraud alert before you've even put your card back in your wallet. How do they do that so fast? Well, it's not magic. It's a completely different way of thinking about how software is built, and it all starts with something called events. Okay, so here's what we're going to cover. First, we'll talk about the problem, why we even needed a new approach. Then we'll get into the good stuff, the core components of EDA. After that, we'll check out the industry standard tools that make it all happen, see some really cool real-world examples, and then wrap it all up with the big picture. Right, so to really get why EDA is such a game changer, we have to start with the problem it was built to fix. And that problem, well, it's kind of the silent killer of speed and innovation in software, tightly coupled systems. Okay, picture this. Imagine a system built like a big, rigid metal chain. Every piece of the system, every service, is a link, and it's directly welded to the next one. Sure, it works, but it's so fragile. I mean, what happens if one link gets a little slow? Or worse, what if it breaks completely? The whole chain just stops. The entire system can grind to a halt. That, right there, is a tightly coupled architecture. And this slide just lays it out perfectly, doesn't it? Over on the left, you've got that old, tightly coupled world. It's monolithic, it's rigid. If you want to change one little thing, you might have to change a bunch of other things. It just slows everything down. But then look at the right. That's the EDA approach. It's loosely coupled, it's reactive. All the parts can operate independently. That gives you so much more flexibility and, honestly, resilience. All right, so if the old way is this brittle chain just waiting to break, how do we get away from that? Well, let's dive into the key players, the fundamental building blocks of event-driven architecture, because this is where the magic really happens. So what is it really? At its core, event-driven architecture is a way of designing software where different systems talk to each other by producing and consuming events. So instead of one system telling another, hey, do this, it just announces that something happened. And then any other part of the system that cares can listen and react. It's all about reacting to things in real time. But what do we mean by an event? It's not just some random message. An event is a fact. It's a record of a significant change in state, like an order was placed, or payment was processed, or item has shipped. These are facts that have happened. You can almost think of them as little newspaper headlines for your system. And honestly, these events are the lifeblood of the whole thing. Okay, in this event-driven world, you've basically got two main characters, the producer and the consumer. It's pretty simple, really. The producer is the application that sees something important happen and then creates and publishes an event about it. It's the one shouting, hey, this just happened. And the consumer? That's any application that's listening for those announcements. It subscribes to the events it cares about and then reacts. But wait a second. How do the producers and consumers even find each other? Well, here's the crucial part. They don't. They don't even know the other exists. They communicate through this middleman called an event broker. And the best way to think about it is like a central post office or a communication hub. Producers just drop off their event messages, and the broker takes care of routing them to all the right consumers. This is the component that makes everything decoupled. Let's walk through a super simple example so you can see it in action. Say you're buying something online. Step 1, you place an order. Your browser is the producer. Step 2, that action creates an order-placed event. Step 3, that event gets sent to the central broker. And now for the cool part, step 4. Multiple consumers can react, totally independently. The inventory system sees the event and says, okay, I'll update the stock count. At the same time, the shipping system sees the same event and says, great, I'll start printing a shipping label. Notice they don't talk to each other at all. They just react to the event. Okay, so that's the theory. But how do people actually build this stuff? Let's talk about the tools that make all this possible. And when it comes to event brokers, there are really two giants in the industry that you'll hear about all the time, Apache Kafka and RabbitMQ. Now, what's so interesting is that even though they both do a similar job, they are built very differently. Look at Apache Kafka. Its core model is what's called a distributed streaming log. You can think of it like a super fast, permanent record of everything that has ever happened. It's an absolute beast for handling insane amounts of data, which is why it's perfect for real-time data pipelines. Then you have RabbitMQ. It's more of a traditional smart message queue. It's incredibly good at complex routing, making sure a message gets exactly where it needs to go, which is fantastic for things like complex task queues.
All right, we've gone through the what and the how. But what about the where? Where does this architecture actually show up in your daily life? And the answer is pretty much everywhere. I mean, EDA is a total game changer in a ton of industries, but its impact is just massive in a few key areas where speed and scale are absolutely critical. We're talking about fintech, logistics and supply chain, and of course, any kind of real-time data application. So let's circle back to that fraud detection question from the beginning. In the world of fintech, this is EDA's killer app. Every single time you swipe your card, a transaction event is created. That event is streamed instantly to a fraud detection service that can analyze patterns in real time and flag or even block a suspicious transaction as it's happening. It's the difference between preventing fraud and just reading a report about it a day later. Or think about the last time you ordered a package online. You know that real-time tracking you're constantly refreshing? That is pure event-driven architecture. Every time your package gets scanned at a facility, it generates an event. Scanned in Memphis, out for delivery. Those events allow all the different systems to update and give you that minute-by-minute status, all the way from the warehouse right to your front door. And of course, in the world of big data and the Internet of Things, or IoT, EDA is the absolute backbone. Imagine you have thousands of sensors sending data every single second. It's just a fire hose of information. EDA is what tames that chaos. It lets you process all those events simultaneously, power live analytics dashboards, and make decisions in milliseconds, not hours.
Okay, so let's zoom out for a second and just look at the big picture here. Why does all of this matter so much? Why has this way of building things become so incredibly dominant? What's the real payoff?
It really boils down to 4 huge advantages. First, it decouples systems. This means different teams can work on their own services without breaking everything else. Second, it enables real-time reactions. You can respond to things instantly, which is a massive competitive edge. Third, it's highly scalable. You can handle enormous amounts of data without the system falling over. And finally, it increases resilience. If one service fails, it doesn't crash the entire application. That rigid chain we talked about, it doesn't break.
And that brings us to a final, pretty big question. Event-driven architecture has given us a digital world that can react instantly. But our world is only getting more connected, right? Data is moving faster and faster. With AI, with IoT, with Web3, we're generating more data than ever before. So what's the next frontier for these real-time systems? What new things will we be able to do? Honestly, figuring that out is probably going to define the next decade of innovation.